let's take a look at what we're going to call the phase shift. Okay, so we have our typical sine. Let's do sine instead of cosine. So we're going to graph that really quickly. We'll do it here in blue. And we remember the first piece is your cosine value. The second is your sine. So at 0 degrees, we have 0. So we plot 0. At 90 degrees, or pi over 2, the sine value is 1. So here at pi over 2, we're right here at 1. Okay, let me erase that one dot there. And then we come here and here and here, and we get our typical graph, right? Now, what if we do this? What if we have the sine of theta and we add 90 degrees to it? We add 90 degrees. What's going to happen? Now, let's just think it through. When we had our typicals 0, 90, 180, 270, 360, which we've graphed right here. We got it right. Here's the graph of that. Our typical sine there, okay? Well, if we're adding 90 to it, that means we've got to do this 0 right here and add 90 to it. So what is 0 plus 90? That's going to make him become 90. And then this 90, when we add 90, is going to become 180. Add 90 there is 270. Everything's shifting, isn't it? 360 and so forth. Now, where's that going to put us? So when you plug in 0 right here for that theta, you're doing 0 plus 90, which so you're now taking the sine of 90. So this is now at 1. So we'll do it in red. 1. So this guy's up here. That's weird. At 180, it's now at what? 0. So, well, when you're at 90, you're basically taking it for 180, which means you're at 0. So you're down here, and then you're here, and then you're here, and then you're here. And this ends up doing this number. So it ended up shifting, didn't it? Now, the weird thing that you would notice, and I drew a better picture here for us, the black line here is the typical sine. This is your typical sine right here. The blue is where I added 90. Now, notice that when you're at this point, when we added 90, it ended up doing what? It shifted back. It shifted back 90 degrees. It doesn't. What happens is when you add 90, you're moving it forward, but the graph itself is going to shift back. It's going to go the opposite of how you think. So if I have sine of theta plus 6 degrees, it's not going to move forward 6 degrees, but it's going to move back 6 degrees. Well, what if I have sine of theta and I subtract 10? Well, instead of going back 10, it's actually going to move what? Forward 10. It's going to go always the opposite of how you think. Now, what we want to do with this is we want to look at our equations where we have our amplitude in there, our period, and now we're looking at the phase shift. So we know the number out front is always our amplitude. That's describing our sort of height, how much it's going up and down and so forth. Okay. The period, we know that the typical graph has a repeating every 360 degrees, one cycle. Well, this is breaking it into 4 cycles. Between 0 and 360, there's going to be 4 cycles. So the period is 4 in this case. And then the phase shift is the number right here. Since it says plus 12, we say, oh, it's actually not going forward 12, but back 12. However, what happens is because of this 4 and this guy gets tightened in, it doesn't go forward 12. We're going to learn that it actually is the 12 divided by whatever number is right there, the period. So it's really only going to shift 3 degrees back. All right, let's take a look at some things. We want to be able to look and say what the amplitude, period, and phase shift. Now, you cannot, okay, the period is describing how many degrees until it repeats itself. That's what we're really talking about, is how many degrees is it going to go until it repeats itself. So typically it's 360 degrees, but when we put a number in right here, it changes things. So amplitude. Amplitude, in this case, number out front, 3. That's a gimme. We'll never miss that question. Now, the period and phase shift are a little bit different. Okay, you can't just go 2 and 10. That's not going to work. Okay, the period is actually how many degrees. That value right here is called your, as we've talked before, that's your B value. And it's telling you how many between 0 and 360. That B value tells you how many times it repeats itself, twice. Our period is always basically 360 divided by whatever number's right there. It's always 360 divided by that B value. Since it repeats itself twice between 0 and 360, we know the period is 180 degrees. The period is telling us, hey, in this graph, every 180 degrees, it's going to repeat. Okay, so the period is how many degrees until it repeats itself. Now, the phase shift, I told you that because this 2 is going to shift it in, it's not going to be exactly 10. Now, do know it says minus 10, so we subtracted 10, but that means it's going to move forward. Okay, it's going to move forward. Our phase shift is always going to be calculated by the opposite of whatever that C is, because again, it goes the opposite way, divided by your B value. So in this case, quite simple, the opposite of negative 10 divided by our B value of 2. Well, the opposite of negative 10 is positive 10, so this is going to shift forward 5 degrees. So the phase shift is forward 5 degrees. Plus 5 is how we would write that. It's that simple. That's all we have to do. The period, 360 divided by B. Phase shift, opposite of C divided by B. And again, this is your C value. That's your B value. So we do a couple problems like that. And again, you can always watch the videos for all the problems that I have for you. The next one is going to say, hey, this time I'm going to tell you the amplitude, the period, how many degrees until it repeats itself, and the phase shift. And I want you to tell me what the equation was. Okay, a little bit more difficult, but not too bad. I do tell you, go ahead and use sine. Sine technically has an E on the end. So it's going to be y equals our amplitude 6 times the sine. Now, I need my B value. There's theta. Right here is going to be my phase shift, my C value. So we know it tells us that the period is 120, but we know the formula for period. The period is always what? 360 divided by your B value, right? So we just write, hey, the period is 360 divided by B. Well, which does it give us? Normally we see the B, but this time we're trying to get the B. And it tells us the period's 120. So here's what we have, 120. And I just put it over 1. It makes life a little bit easier. And now we cross multiply. Okay, butterfly effect. Some of you might like it called that. We divide by 120. You should be able to see, hey, B is a 3 here. So I now know that's got to be a 3. And I could sort of see that, hey, if every 120 degrees it repeats itself, between 0 and 360, it's going to do it 3 times. Okay, it's going to repeat itself 3 times there if it's repeating every 120. Now, the phase shift. Don't make this harder than it is. The phase shift is simply the opposite of the C value divided by B. Well, we just found B. It tells us the phase shift is 4, so I just plug in my numbers. 4 over 1. The opposite of C over, what did we find B to be? B we just found to be a 3. So now across multiply, I get negative C times 1, negative C, opposite of C technically. 4 times 3 is 12. Now you simply multiply both sides. C is going to be a negative 12, so we need to put a minus 12 there. And that's all we got to do. The biggest mistake we usually make is right there. We just seem to not do it. We just seem to want to write 4 in there. But you have to do the opposite of C to make it go the opposite direction, divided by the B value. Again, I've done almost all the homework problems for you, so watch those videos to help it make a little more sense to you if you're struggling here.